friends, today I am going to solve LeetCode problem number 2477, minimum fuel cost to report to the capital. So in this problem we are given an array nodes roads where each element in the roads array represents a bidirectional connection between the two nodes. Basically these two nodes are cities and there is a bidirectional road between these two nodes, and we are also given an integer seats where the value of seats represents the number of seats available in each car. So basically from each city, that is from each node, we have one representative, and that one representative goes to the capital city. So basically that's the node 0, and well, those representatives can share their seats in their car. So now that we need to figure out the minimum number of liters of fuel to reach the capital city, and to reach from one node to another node, the amount of fuel cost is equals to 1 liter. So now that we understand the concept, let's start to solve the problem. Alright, so before that, let's look at this example. Okay, so we are given the roads array which has this value, and the number of seats is equals to 5, and we have total number of 4 nodes, each of them starting from 0 to m-1, that is equals to 3. So we need to reach from node all of the other nodes to the capital city, that is node 0. So how are we going to find the amount in liters to reach the capital city? Well, the number of cities equals to 5, so maximum number of representatives that can be occupied in a car is equals to 5. So we start from the node 0, that is our root node here, and we do a DFS search. So we go to one of our neighbor, and then until and unless we reach the leaf node, right? So since this is a leaf node, now what we do is what's the number of nodes, the number of representatives so far that we have encountered, so that's equals to 1. So the number of representatives here is equals to 1, right? So for one representative to reach from this node to this node is equals to 1, and the number of seats is equals to 5, so that would still be one car, right? So what we do is 1 by 5, we take the ceiling value, which will be equals to 1, so the amount in liter is equals to 1. Similarly, from this node we need amount 1 liter, from this node we need 1 liter. So now in the end we add all of these values, so the amount in liters, the result is equals to 3. Now let's look at more complex problem, that is this example here. So we are given this example which consists of 7 nodes starting from 0 to m-1, that is 6, and the number of seats is equals to 2. We start from our root node and we perform DFS. So what we do is from root node 0 we move to one of its neighbors. So let's just choose this node first, and we keep on going until we reach our leaf node, because that's a DFS solution, right? We keep on moving until we reach the leaf node, and once we reach the leaf node, now we calculate the number of representatives, and then we update our result. So what's the number of representatives so far? That's equals to 1, right, when in this node, so that would be plus 1. So initially this value is equals to 0 and the result is also equals to 0. So the representatives plus 1, which means that total number of representatives is 1, right? And for this node to move from this to this node, the amount of fuel that will cost will be equals to the value of representatives, which is equals to 1 divided by the number of seats, that's equals to 2, and we take the ceiling value of these values, so that would be equals to 1, right? So now our result is equals to 1, the number of representatives here is equals to 1. And then what we do is we pass the number of representatives that we have found so far in this subtree to our parent tree, or the tree or the node that we have called from. So we pass the value 1 here, and now the number of representatives of this node is equals to 1 as well, right? So we add that number to our result that we passed from here, so that would be plus 1 again. So every time basically we are adding plus 1 to our representatives, and this value becomes equals to 2. Now our new value for representative is equals to 2, and the number of liters would be 2 by 2, that is equals to 1, because both of them can go in same car, right? And same car, which means that one car, they're only using one car, and for one car it takes 1 liters here. So now the total number of representatives is 2 plus 1, and the result is 1 plus 1 equals to 2. Similarly, we are going to do the same thing here. So the number of representatives is, from these two nodes we have the number of representatives equals to 2 plus 1 for this node itself, so that's equals to 3, and the number of cars we'll require is equals to 2, because the number of seats is only 2. So in one car we can occupy maximum of 2 people, so one car with 2 people and the next car with 1 representative. So basically there will be 2 cars, right? So our result will increase by 2, so the value will be equals to 4. So 4 from this subtree. Now what about these here? Let's just look at it. So we start from here, the number of representative is 1, so basically the result will increase by plus 1 because only 1 car is needed. And then we move here, the number of representative here is 1 plus the value from this, that is equals to 2, so the cars we need is equals to 1, so that will be 2. So at that point we reach our capital, and for here also the number of car we need is 1, so the amount of fuel consumed is equals to plus 1, so that would be total of 4, and this is a value of 3, right? So 4 plus 3 equals to 7, so that is our final result. So basically what are we doing here is, just let me just give you an overview here. So we are performing a DFS search, so we move towards the leaf node, and then we find a number of representatives in each subtree, and we pass that number of representatives to our parent node every time, because all the representatives are going to the capital city, right? So representative from this city, this city, this city are all going to the capital city, so the number will keep on increasing. So that's why we are adding the number of representatives from all the subtree to its parent node, and then computing our result. Now let's look at our code. So start coding. So here what are we given is the roads array, right? And this roads array consists of the nodes or the cities and the connection between them, and we are given that it's a tree with undirected graph and no cycle. So basically there would be total of, if there are n nodes, then there would be total of n minus 1 number of connections, right? So that is why the length of road, the number of roads, basically the number of nodes would be plus 1, that because there are only n minus 1 connections, right? So n minus 1 connections plus 1 would be equals to n here. Now we check if n is equals to 0, if roads.length is equals to 0, that is there is no connection, only one node, then we are going to return for 0, because there is only one node, that is only node 0, city 0, so we don't need any fuel, right? Now next what are we going to do is we are going to form our adjacency list, where we are going to store the neighbor of each node. So we are going to form adjacency list of length n, and then for let I equals to 0, I is less than n, I plus plus for each of the node will also, each of the like element in an adjacency list is also an array, because we are going to store all the neighbors, right, in an array, so that would be an array. All right, okay, now we formed our array. We are going to fill our adjacency list with the values of roads. So adjacency list at index 0, we are going to push its neighbor, and its neighbor would be at index 1. Similarly for adjacency list at index 1, road at index 1, we are going to push its neighbor, that would be at index 0, because 0 and 1 both are connected in a bidirectional way. So 0 is connected to 1 and 1 is also connected to 0. All right, so now we have formed our adjacency list. We are going to create our DFS function. So what are we going to pass to our DFS function? We need to pass the node that we are currently present at, the parent node, or the node that we called from, because we do not want to, node 0 is connected to node 2 and node 2 is also connected to node 0. We do not want to go in a loop, so that's why we are going to use a parent node, so that if its neighbor is equals to the parent node, then we do not continue our operations. So next is the number of representatives. All right, and then we will also need to store our result in an integer, so we are going to return that result at the end. Now for each of the neighbor of this node, okay, so we have our node, our parent, and the representatives. All right, we actually do not need this here. We are going to pass node 0, the parent of node 0 is -1, and the number of representatives so far we have encountered is equals to 0. Okay, so for each of the neighbor of the adjacency of the node 0 of this node, we are going to perform the DFS function. So basically we are going to call a DFS function. If parent is equals to neighbor, then we just continue with the next node, else we perform DFS with our neighbor, comma, the node becomes the parent, and the representatives, we pass our representatives. So what are we going to do here is, okay, the local number of representatives. So what's the number of representatives so far in node 2 before we make any iterations? The number of representatives in the number on in the neighbors of node 2. So it's starting from 0, and each time we update that value by 1 by the number of representatives returned from its child, because, and then finally our number of becomes equals to the result, the local representatives plus 1, that is the total number of representatives from its neighbors plus the number of representatives from the city itself. plus 1, and then our result would be equals to, so we are going to take the ceiling value, right? So the number of, okay, REP, RE as in representatives divided by the seats, the number of seats available, and then finally we are going to return the number of representatives. Okay, so we are only going to need to update our result as long as we have not reached the node 0, right? Once we have reached node 0, we do not need to update our result because we are no more going to commute, right? We are only going to commute from node 2 to 1 to 0, 1 to 0, 3 to 0. Once we have reached here, we are not going to perform any operation. So that's why if node is equals to 0, we are just going to return 0. So now that we have performed all our operations, let's try to run our code and look for any errors. Okay, so this is actually P. Yeah, that's the mistake I do because it's the Cool. So now the time complexity and the space complexity. Let's look at the space complexity first. So this is O of n, space complexity, because we are creating an array, and the time complexity is also O of n for this one, same for this. So we are also performing a DFS operation, and in the DFS operation we are only iterating over one node once, right? So that would be O of n.